In this lecture, we will start study of Epsilon NFA. NFA has two types: NFA without epsilon transitions, NFA with epsilon transitions, which we call as Epsilon NFA. Now, if we consider 5-tuple definition of NFA, it is Q sigma delta Q0F. Now, transition function of NFA is delta Q cross sigma union epsilon goes to power set of Q. So what it means is, at any state, either you process a symbol or epsilon and you will go to some subset of Q. So in Epsilon NFA, you will find transitions like this. From a particular state, you process epsilon and you go to next state. Now, if you consider a string, then finite automata processes a string from left to right. In Epsilon NFA, while processing the string, either you process next input symbol in the string or you process epsilon. So in Epsilon NFA, either you process a symbol 0, 1 or more number of times and you go to some subset of Q, or you process epsilon 0, 1 or more number of times and you go to some subset of Q. Now we will consider this example and understand how Epsilon NFA processes a string. Now consider string 001. Now we start from initial state P. First we process 0. So P on 0 remains in P. Then we process next 0. P on 0 again remains in P. Now here next input symbol is 1. Here we do not have transition for 1, but we have transition for epsilon. So now we process epsilon. P on epsilon goes to Q. Now we process 1. Q on 1 goes to R. And now the string has ended, but still we can process epsilon. So after 1, we process epsilon and R on epsilon goes to S. S is a final state and the string is accepted. So this is not a string, this is a concatenation operation and its result is 001. So here there is at least one transition sequence for which the NFA ends in a final state, so string 001 is accepted. If you consider string 011, then here P on 0 remains in P, then you can process epsilon, go to Q, then you process 1 and go to R. Now we have processed 0 and 1. Now for this last one, we are over here, we are in state R. Now here also we do not have any transition for this one. Here also, even if we process epsilon, we don't have transition for 1. So for string 011, we do not have any transition sequence which ends in final state. So this string is not accepted. Now for better understanding of Epsilon NFA, we will consider some languages and construct Epsilon NFA for those languages. Before we proceed with examples of Epsilon NFA, let's understand one small important point. If you consider this transition function, Q cross sigma goes to power set of Q, then here we are not processing epsilon. So this transition function is for NFA without epsilon transitions. So this transition function, it covers only this part. If you consider delta Q cross sigma union epsilon goes to power set of Q, then it covers both types. This is the transition function. This is the transition function for NFA. If you consider this transition function, it covers both types of NFA. If you are asked what is transition function of NFA, then this is the correct answer. Consider first example. Language L is A power K, B power M, A power N such that K, M, N greater than or equal to 0. So consider string A, B, 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 A. This string follows the given form. This string is part of the language. Now value of K, M, N can be 0 or greater than 0. If we consider A power 0, B power 0, A power 0, we get epsilon. This string should also be accepted by NFA. Consider initial state P. So here we add loop for A. Then we take epsilon transition, go to state Q. Here we process B. And again we take epsilon transition, go to state R. And here we again add loop for A. We mark this state as final state. Now if you consider string epsilon, then we simply take P epsilon Q, Q epsilon R, we reach to final state. String epsilon is accepted. For this string A, epsilon B, 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 epsilon A, the string is accepted. So this is the required NFA. Consider next language. Language L is W such that W contains at most two A's. So string should contain at most 2 A's, not more than 2. Consider initial state P. Now we do not have any constraint for how many B's should be there. So we have to add loop for B. We should not miss this transition. Now here we can take transition for A or epsilon. Go to state Q. Here also we have to process B, and then again we take transition for A or epsilon. We reach to a final state R, and here also we have to add transition for B. So if you consider simply string epsilon, this does not have any number of A's or 0 number of A's, it should be accepted. So epsilon we reach to final state, string epsilon is accepted. If we consider string BB, then B, epsilon, it is accepted. For BAB, then BA, B, epsilon, string is accepted. So this is the required NFA. Now here language L is W such that length of W is less than or equal to 3. So consider initial state P. Now condition is string length is less than or equal to 3. So first we process A, B or epsilon, go to state Q. Again we process A, B or epsilon, go to state R. And again we process A, B or epsilon and go to a final state S. So if we consider string epsilon, length is 0, it is less than or equal to 3. So epsilon, we reach to final state, it is accepted. For string BA, so here we process B, then process A, and now we process epsilon and we go to final state. So BA is accepted. If you consider string with length more than 3, say AB, then A, B, A, we reach to state S. We do not have any transition for B. This string is rejected. So this is the required epsilon NFA. Consider next language L, W such that W is a suffix of ABAA. Consider string ABAA. Now what are the suffixes of this string? Epsilon, then A, AA, BAA, and then ABAA. So the epsilon NFA we are going to design, it should accept only these strings. So consider initial state P. Now from here we have to process A, B, A, and then A. Now this NFA should accept ABAA. We mark this state as final state. We will name the states also. Now we have to accept epsilon. So from P, we add transition to T and we process epsilon. Now we have to accept A. A is a suffix. It is over here. So from P, we add this transition. So we process epsilon dot A. So epsilon A, string A is accepted. Now we have to accept AA. AA is over here. We add this transition. So epsilon AA, epsilon AA, the string is accepted. For BAA, similarly we add transition over here. This is epsilon move. So we have accepted BAA also, epsilon BAA, and ABAA, we accept this string also. So this is the required NFA, epsilon NFA. It accepts these strings and it does not accept any other string. If we consider any other string, BBA, then here there is no transition sequence that ends in final state for BBA. So this string is not accepted. This is the required epsilon NFA. Consider next language. Language L is W such that length of W is divisible by 2 or 3. Now consider language L1, W such that length of W is divisible by 2. Consider language L2, W such that length of W is divisible by 3. If we consider L1 and L2 like this, then language L is L1 union L2. This language L is L1 union L2. Now let's first construct NFA for L1. So length of W is divisible by 2. We require 2 states. So this is initial state. We mark it as final state, and total we require 2 states. So here we can process A or B. We take the loop. Here also we can process A or B. Now let's construct NFA for L2. Length is divisible by 3. So here we require 3 states. We take initial state. We mark it as final state. We require total 3 states. Here we can process A or B. Here we can process A or B. Then we take the loop, and here also we can process A or B. Now using these 2 NFAs, we will construct NFA for the given language L. L is L1 union L2. So we take another initial state, and from here we add epsilon transition to this NFA, and similarly another epsilon transition to NFA of L2. So if the string length is divisible by 2, it will be accepted over here. If the string length is divisible by 3, it will be accepted over here. For string AB, epsilon AB accepted over here. String BAB, epsilon BAB, it is accepted over here. Now if the string length is neither divisible by 2 nor divisible by 3, consider AB, ABB. So epsilon AB, ABB, it reaches to non-final state. Here also epsilon AB, ABB, it reaches to non-final state. So this string is not accepted by the NFA. So this is the required NFA for language L. L is L1 union L2. So this is to give you idea how you can use epsilon moves to construct NFA for a language which is union of 2 other languages. So language L is union of two regular languages, L1 is regular, you construct NFA for L1, L2 is regular, you construct NFA for L2, and then we add epsilon moves to L1 and L2 and we get NFA for L. So this is a required epsilon NFA.